All right. So in this section, we're going to talk about the idea of logic and deductive reasoning. And over the next couple of sections, we're going to develop the idea of logic, which is part of the language of mathematics, along with sets and algebra, which we've talked about a little bit. And again, we're not going to cover the entire gamut of things. That would take a very, very long time over many courses, but just enough that we can have intelligent conversations in this course and say things precisely. Mathematics is a very precise language. We want to make sure we know exactly what we mean when we write down or say something. And those ideas are going to be covered in logic and sets. And kind of the idea with logic, we're going to build up some tools so that we know precisely the difference and similarities of these two sentences. All even numbers and then 2, 4, 6, 8, and 0. Or all numbers ending in, say, a 2 or 6 are even. Both of them are true if you think about that. They're obviously true. One of them's a little stronger than the other. This one covers absolutely all cases of even numbers, but this in some sense doesn't. It's not wrong. All numbers ending in a 2 or 6 are even, but you're missing out on some cases. So they're examples of situations where logic is going to be important to us. We'll see situations like this come up, and in your teaching career, you will see situations come up where you're dealing with kind of these if-then statements or all statements or some statements, and we want to know what they mean exactly. So we need to develop a little bit of notation and definitions before we start a topic, and that'll be kind of what happens whenever we start a new section. We will introduce some terms and some notation so that we have some things to work with. So the first things we need to talk about are types of sentences. And both of them appear in mathematics a whole lot. In fact, in everyday life, a whole lot. So the first one is called a statement. And a statement is a sentence, but it's a sentence where you can say it's either true or false. So anything that is either definitively true or false, we call a statement. So examples 1 and 2 below are examples of statements. 3 plus 4 equals 8. Well, no it doesn't. 3 plus 4 equals 7. This is false. So it's a false statement, but it is a statement, because we can say if it is true or false. The second one, the University of Winnipeg, is in Canada. Well, that is true. The University of Winnipeg is indeed in Canada. That's true. That is a true statement, so this is indeed a statement. An open sentence is kind of like a statement with a variable, or it becomes a statement when you plug in an appropriate value for your variable. So here's two that where we're allowed to plug in integers. And it's a good idea, and this is called kind of the domain, what you're allowed to plug in. So the domain for these open sentences are integers, because that's what we're told. And the first one is x squared equals 1. So we have to ask, well, what integers can we plug into this so that it is true? Well, we know 1 times 1 is 1, so it's true when x equals 1. But it's also true when x equals negative 1, because negative 1 times negative 1 is positive 1. So it's true for two values, for 1 and negative 1. So you could either write as a list like that, 1, negative 1, but sometimes you'll see people write, if it's the same value, just a positive and negative, they'll write a little plus minus. So it's true when x is plus or minus 1, and false otherwise. For, we have x is greater than or equal to 4. So this is true for x. It could be, well, 4 is greater than or equal to 4. 5 is greater than or equal to 4. 6 is, all the way to infinity. And it's false. You could either say false otherwise, or you could list exactly what values make this false. If we plug in 3, 3 is not greater than or equal to 4. This is not true. If we plug in 3 for x, this is a false statement. So it's false when we plug in anything else. So 3, 2, 1, 0, -1, all the way to negative infinity. Remember, your integers are all positive and negative whole numbers along with 0, of course. So there are statements and open sentences. And then sometimes there are sentences that are neither statements or open sentences, like, what time is it? Well, it's not a true or false statement. It is just a question. It doesn't have a truth value. There's no variable. So this is neither. And maybe let's do one more open sentence example. So let's do the following. So let's do this one. Patrick Liney plays for hockey team let's use the variable h. Now I need to tell you what h can be, what the domain is. So h is an NHL team. And right now Patrick Liney is a Winnipeg Jet. So this is true when H is the Jets, and false for any other hockey team. So they are statements and open sentences. All right, so here we have two different compound statements. What I mean by a compound statement is we're taking two statements and we're joining them together with either the words and, in example 1, or. So this one is written a little bit differently, but it's not too bad to see it as two compound statements. So in English you would say I have a dog and a cat, but you could reword this to say I have a dog and I have a cat. So we could think of the first statement, because I don't want to write down I have a dog as the first statement over and over again. That takes a lot of time and effort. So I'm just going to name that P. So the first statement, I have a dog, I'm going to call P. And I have a cat, I'm going to call statement Q. Now, you don't know if I have a dog or a cat or both or neither. So let's see what happens in every possibility. And let's see if the compound statement, I have a dog and I have a cat, when that is true. So let's work out all possible truth values for both P and Q. So, well, maybe it's true that I do have a dog and I do have a cat. Well, maybe I just have a dog and no cat. Or maybe I have no dog, but I have a cat. Or maybe I have neither. So these are all four situations that I can possibly have with these truth values. Both are true, neither are true, or one or the other is true. Both, neither, one, or the other. So the question is, if you read this, I have a dog and I have a cat, when is that statement true? Well, if you think about it, it's only true when both parts, P, where I have a dog, and Q, where I have a cat, when that is true. So I'm telling the truth then. But if I only have one, if I just have a dog, if I say I have a dog and I have a cat, I'm lying to you. That's false. Same if I have just a cat. Then if I say I have a dog and I have a cat, that's false. And of course, if I have neither, that's false as well. So, There's nothing kind of special about this having a dog and having a cat. They're just two statements. The whole idea is that both of the constituent statements that make up the compound statement, they need to be true in order for the and to be true. So the rule is the compound statement P and Q is true exactly when both P, or let's say it's written like this. Let's say exactly when P is true and Q is true. And when I say this exactly when, what I mean by that is I'm telling you when it's true, but I'm not leaving any cases out. So these are all cases when true. So when I say exactly when, it means whatever I say after that, that covers all of my bases. So that's the rule for and statements. Let's look at or statements. Let's say Alice or Bob will get married this year. That's our second one. This one's a little bit trickier because we have to decide something that we'll see eventually. Again, let's write down all possible scenarios with P and Q. So P is Alice will get married this year. Q is Bob will get married this year. Maybe they both get married. Maybe just Alice gets married. Maybe just Bob gets married. Or maybe neither gets married. So there's going to be two easy cases. Or in some sense, three easy cases. So if neither of them get married, if I say Alice or Bob will get married this year, well, then I lied to you. That is obviously false. Neither of them got married, so Alice or Bob will get married this year is a false statement. Well, what if just Bob got married? Well, if just Bob got married, if I said Alice or Bob will get married this year, well, I'm telling the truth. And similarly, if Alice gets married, then Alice or Bob will get married this year is a true statement as well. And now it's the case, what happens if they both get married this year? Am I lying to you? And here we have to kind of make a decision. We have to decide if it's an inclusive or exclusive or, if we want to include in the word or the idea of or both. And in mathematics, we find that it's more useful to treat the word or like an inclusive or. So if both happen, then we still say that you're not being lied to. So if both Alice and Bob get married this year, then we're going to say that the truth value of the compound or statement is still true. So if you look at this, this is almost a mirror image of the and, but instead of only being true when both are true, this is only false when both are false. So let's say here, P and Q, P or Q is false exactly when, which means this is all of the times it is false, exactly when P is false and Q is false. So that is the compound statements for and or. We'll move on to the next bit and we'll talk about negating things. So what does the word not mean?